Good afternoon, all. Welcome to discussion session of plates and cells. The course instructor of this course is Professor Sudeep Talukdar, and I am your teaching assistant. Myself, Asif Raza. I am a PhD scholar from Department of Civil Engineering, ISC Bangalore. So today we are going to discuss questions relevant to assignment 3. So without any more delay, let's start. So the first question is, the Levy's formulation can be directly used in. So the first option is a rectangular plate simply supported along four edges. Second option is a rectangular plate simply supported along two opposite edges. And the third option is rectangular plates where all edges are clamped. And the fourth option is the option number 1 and 2 both. So as you have all studied, Levy's formulation is used for a case where Levy's formulation is used where the plate is simply supported at least along one pair of opposite sides. Meaning to say that the plate is simply supported at least at one pair of opposite sides. So if I take this would mean the option B would be correct. And there is also a case where all the edges could be simply supported, which also specifies the first option. So with these two conditions being true, our correct option would be option D. The second question would be, a rectangular plate whose two edges x equal to 0 and x equal to a are simply supported is to be solved by Levy's method. Other edges y equal to 0, y equal to b is free. The solution can be obtained using following series. So the given condition is that x equal to 0, if I take this as x and this as y. So our given condition is that x equal to 0 and at x equal to a, it's simply supported, while at y equal to 0 and y equal to b, it's clamped. So this can be solved by Levy's method. Uh, we can also uh, eliminate using the boundary conditions of the case, as what will we have? We'll have w equal to 0 at x equal to 0, at x equal to a, y equal to 0 and y equal to b, isn't it? So if we use this condition, x equal to 0 and x equal to a, so with this we should get either sine function of like sine m pi x by a or sine m pi y by b. But if we have Levy's method, and Levy's method specifies about the boundary condition with respect to simply supported, so we have with respect to x equal to 0 and x equal to a. So more prominently, the boundary condition in the displacement function would be having sine m pi x by a. So with this we'll have this option, and yeah, so the correct option would be 2a. You can also uh, verify it by applying it to the boundary condition. Like the boundary condition would be at x equal to 0, you would have boundary condition at w equal to 0 and del square w del uh, x square equal to 0. Similarly, at x equal to a, would be having w equal to 0 and del square w del x square equal to 0, right? At y equal to 0 would be having w equal to 0 and del w del y equal to 0 and that y equal to b would be having w equal to 0 and del w del y equal to 0. You are substituting this condition also will get this. Okay, so let's move on to the second option, third question. So we are given with the question a hydrostatic load Q equal to P x upon a acts on a plate of size A by B with the flexible rigidity of the plate to be as D. The plate is simply supported at x equal to 0 and x equal to A. In order to find out deflection in the form W equal to Fx from Gy, the following differential equation is to be solved to find Gy. Okay, and the expression for Fy will be. So we are given with the condition it's simply supported at x equal to 0 and x equal to A. So for this we have simply supported condition at x equal to 0 and A. For this we have Fy is equal to 0 integral 2 upon A d q sine m pi x upon A dx. Okay, and if we take m equal to 1, we'll get Fy is equal to 0 to A upon d. Q we have the given value as px upon A sine pi x upon A dx. Okay, so using integration by parts, we can simplify this first. To okay, so we can take 2a square d p. So we have sine x sine pi x upon dx. So integration by parts, you would get Fy is equal to, so let's see, we are having 2p a square d 0 to a x sine pi x upon a dx. Integration by parts, so integration by parts will give me this will give me minus cos pi x upon a pi by a. This is from 0 to a, integration 0 to a, differentiation of first part, then integration of the second part, cos pi x upon a pi by a dx. So this again, so this would be a cos pi, this will give me minus cos pi upon pi by a minus 0, that will cancel out. So what this would be plus 1 upon pi by a, and on integration it will give me sin pi x by a, limit from 0 to a. So this is equal to p a square t, cos pi is minus 1, so minus minus 1, 1, so this is a square upon pi, and this would be a by pi, oh sorry, I left it out this thing, so this would be a square pi square sin pi, this would be 0. So finally we would be having 2p on pi d. Okay, so fy is to p upon pi d. Integration by parts is like v dx, so v dx minus dy dx v dx dx. Okay, so fy is equal to 2p upon pi d, so answer would be first option. Now question number 4. A rectangular plate simply supported along edge x equal to 0 and x equal to a is subjected to uniformly distributed load. The x-axis is taken through the midpoint of the vertical edges. The plate is fixed along edge y equal to plus minus b by 2. According to Levi's formulation, we have the displacement expression as given as this, in which c is constant term representing particular integral of the solution of plate equation. For a plate whose aspect ratio a by b is equal to 2, so first what we have is a rectangular plate. The plate is fixed along, so we have the x-axis taken to the midpoint. So if we take this, so x is this, y is this, so this would be x equal to 0, x equal to a, y equal to b by 2, and y equal to minus b by 2. So we are given that this is simply supported and this edge is fixed. Okay, a simply supported line is subjected to UDL. So we are given with a uniformly distributed load Q. The x-axis dimension of the plate is fixed at this point. Okay, so we begin with this, and we have a by b as equal to 2. So what do we have? We have the expression of w is equal to a cos a pi y by a plus b sin a pi y by a plus c sin pi x by a. Okay, as we have the fixed boundary condition at y equal to b by 2, plus minus b by 2, so we have the condition at y equal to plus minus b by 2 would be having w equal to 0 and del w del y equal to 0. Okay, so let's substitute this and use this. So if we take y equal to v by 2 and condition W equal to 0. So W is equal to A cos H by B by B by 2A. Okay, so this won't take us anywhere. Rather than, let's find first del W by del Y. So del W by del Y would be del by del Y of A cos H pi Y by A plus B sin H pi Y by A plus C sin pi X by A. So this would be A sin H pi Y by A plus pi by A B cos H pi Y by A by pi by A. Oh, why am I taking as a denominator? I should take it as pi Y by A times pi by A. Likewise, B cos H pi Y by A times pi by A plus, if C is a particular integral, so this would be 0, and multiply term sin pi X by A. Correct? Am I missing something? Complex. Okay, so there is a missing term. Here it would be By. Here it would be By. Yes, here it is By. It would be By. So pi by A plus it becomes, if I take B sin A pi Y by A times sin pi X by A. No, it's fine. This goes, yeah. Okay, so now let's substitute the condition that at y equal to b by 2 we have del w or del y equal to 0. So del w by del y at b by 2 equals to y equal to 2 is a sin h by b by 2. Okay, times pi by a plus b cos a. Okay, rather than making some thing, let's see, pi y by a, pi y by a is pi b by 2a, and we have b by a equal to 2, so this becomes 2, this becomes pi. So ultimately it will be have sin h pi into pi by a plus b cos h pi into pi plus b sin h pi times sin pi x by a. So substituting this, we'll be having this. So this is equal to, so we have sin Oh, there's a mistake. A by B is equal to 2. We have A by B is equal to 2. So this becomes 1 by 2 pi by 4. So this is pi by 4, pi by 4, pi by 4. And this is pi by A, pi by 4. Okay. So now let's take it out. So we have A, pi by A, sin H, pi by 4 plus B, pi by 4 cos H, pi by 4 plus sin H, sin H, pi by 4 times sin pi x by A, which is equal to 0. So this can be simplified as A by B is equal to we take it as take this as a 0, this part equal to 0. So we will be having minus pi by 4 cos H pi by 4 plus sin H pi by 4 by pi by A sin H pi by 4. If I take sin H pi by 4 as common, so this becomes cos upon sin, this will become cot H pi by 4, cot H pi by 4 plus 1 upon pi by A. So this again can be simplified as A upon pi by 4 cot H pi by 4 plus 1. We have the options. Okay, so we have B in all the options. So we are given with A by B is equal to 2. This gives A equals to 2B. Substitute this. So 2B 2B upon pi by 4 cot H pi by 4 plus 1. So multiplying this will get minus B. Pi cancel out. This becomes 1 by 2 cot H pi by 4 plus 2 by pi. Correct? This is my A by B. So the correct option is A by B is minus B. Okay, so this is 2 by pi and 1 by 2 cot H pi by 4. The correct option would be option A. Okay. Now let's move on to the fifth question. There is a square plate. There is a square plate whose side is A, carries a util q per unit area, taking x-axis passing through the center of the plate, edges x equal to 0 and x are simply supported, and the other two edges are claimed. The deflection at the center is this. So we have the plate, a square plate. So let's make it more. And the x-axis passing through the metal, edges x equal to 0 and x equal to a are clamped, sorry, fixed. Simply supported, the other two edges are clamped. So this is 0, this is a, this is y equal to minus a by 2, and this is y equal to a by 2. This is x equal to a and x equal to 0. Okay, so deflection using Levi's method will be having wxy is equal to m equal to 1 to infinity y and y sine pi x upon a, correct, and pi x by a. Where y can be written as AMY cos h m pi y by a plus PMY sin h m pi y upon a plus c, where there is a particular interval. For UTL we have 4q a to the power 4 d pi I m pi. So if you see the lectures, we have the value of am as minus 4q a to the power 4 d pi phi m pi, and this would be sin h m pi by 2 plus m pi by 2 cos h m pi by 2 upon cos h m pi by 2 sin h m pi by 2 plus m pi by 2. Similarly for Bm we have 4q 4 d pi phi m phi m pi by a sin h m pi by 2 upon cos, the denominator would be same as cos h m pi by 2 sin h m pi by 2 plus m pi by 2. So if we take m equal to 1, so take m equal to 1, m equal to 1, and we have to find the deflection at the center. So the center is at x equal to a by 2 and y equal to 0. So take m equal to 1, x equal to a by 2 and y equal to 0. We would be having w a by 2 comma 0 as, and only taking the first y1. So this will be like y1 y, this, that is 0 sin pi by 2. So equals to y1 of 0. Now y1 of 0 would be equal to a1, right, cos h m pi 0. So cos h 0, that would be 1 plus d1, this would b1y, b1 times 0, so rest of the terms will be 0, and the constant part, that is 4q a to the power 4 d to the power d pi to the power 5 into 1. So this okay. So only we have a1 plus 4q a4 d pi 5, and what we have a1 as, a1 is equal to minus 4q to the power 4 upon d pi 5 sin h pi by 2 plus pi by 2 sin cosine h pi by 2, then cosine h pi by 2 sin h pi by 2 plus pi by 2. Okay, so cos h common, make it as minus 0.011 q e to the power 4 d. This gives wa by 2 comma 0 is minus 0.011 q to the power 4 d plus 4q 4 by 5 by 5 q e to the power 4 by d. This again, when you simplify, it gives 1.97 into 10 minus 3 q e to the power 4 d, which is equal to 0.00197 q e to the power 4 by d. It's better to remember this one. And we have include a by 2 comma 0 as this, and we were given with k q a4 by d. So k equal to 0.00197. Answer is this. Okay, let's move on to the next question. So with reference to the previous question, the magnitude of the maximum bending moment Newton per meter at the hy equal to plus minus 5 by 0.5 by a 0.5 a, taking a equal to 60 centimeter, h equal to 1 centimeter, q equal to 500 Newton per meter square, e equal to 200 gigapascal. Poisson's ratio as 0.3. Correct up to second decimal place is. So for the moment we'll have, okay, so first let's draw the previous diagram. What do we have? We were having a square plate x y x equal to 0, x equal to a, y equal to a by 2, equal to minus a by 2, and we have the simply supported condition here and the fixed condition this point. So we know the maximum bending moment, if we see along x-axis, at the edges it will be 0 with the boundary condition. So we need to we'll take the bending moment along y, and that is equals to my minus d del square w del y square plus mu del square w del x square. Okay. Now using Levi's method, we have, if we summation m equal to 1 to infinity y sin m by x by a, correct? So take m equal to 1. Will be having 1 y sin m by x by a, that is equal to a1 cos h pi y by a plus b1 y sin h pi y by a plus 4 cube e to the power 4 t by 5 sin by x by a. Okay, now we have let's find del w del y. For before that, del w del y would be equal to a1 sin h pi y by a times pi by a plus b1 y cos h pi y by a times pi by a plus sin h pi y by a. That will give me 0 multiplied with sin pi x by a. Now del square w by del y square would be equal to a1 pi by cos h pi y by a pi by a whole square. Okay, and this would be v1 y so this is y sin h pi y by a pi by a whole square and cos h pi y by a plus this is sin h, and this is also cos h pi y by a pi by a. Good. And this is sin pi x by a. Now del square w del x square. So first let's find del w by del x. I wrote w as y1 sin by x by a. This is function. So del w by del x would be y1 of y sin this would be cos by x by a times pi by a, and del square w by del x square would be y1 by minus sin by x by a pi by a whole square. Correct. So we have 1, 2 and 3. So substitute 2 and 3 in 1, we get m y is equal to minus t. Cos h by y by a plus b1 y by a whole square sin h by y by a plus 2 pi by a cosine h by y by a. This is multiplied with sin pi x by a plus nu times nu y1y. y1y is again a1 cos h by y by a plus b1 y sin h by y by a plus 4q to the power 4 d by 5. Into minus sin pi x by a into pi by a whole square. So this is something we need to simplify. So we can again write it as so thing is so what do we have as a1? If we take a1 consider this can be simplified as minus t So we have a1 as pi by a square minus nu pi by a. So a1 pi by a whole square 1 minus nu cosine h pi y by a is first term, then b1 as b1 as pi by a whole square y minus y 1 minus nu sin h pi y by a and 2 pi a cos h pi y by a plus minus nu 4q a4 d pi 5 times sin pi x by a. This is my my. Okay, so as of now we have my as this. To find a1, we had a1 as this and b1 as this. So with this we got a1 equal to 0.0. So taking it from the previous, we have minus 0.00111. Let me check. Okay, this is single 0. Point 0.011 q a to the power 4 by d. Okay, now let's find b1. So b1 would be equal to 4qa for 4 d by 5 and 4qa to the power 4 d to the power 5 times m pi by a. That could be pi by a sin h pi by 2 pi by a sin h pi by 2 divided by cos h pi by 2 sin h pi by 2 plus pi by 2. Let's check it. So with this we get now okay, so b1 a1. Okay, so we are given with equal to 60 centimeter. We are given with a equal to 60 centimeter, h equal to 1 centimeter and e equal to 200 gigapascal. So d becomes ehq 12 1 minus nu square. Nu is equal to 0.3. So e 200 so this is equal to 2 into 10 power 11. H is 10 power minus 2 into cube by 12 1 minus 0.3 whole square. So this is equal to 18315.0183 Newton per meter square. Okay, so when we substitute this value, given that q is equal to 500 Newton per meter square. So when we substitute these values in A1 and B1, we get B1 equals to B1 is equal to 7.586 into 10 power minus 5, and A1 is equal to, let me check, 0.0 into 500 into 0.6 divided by 18315. 3.927 to 10 power minus 5. Substitute A1 and B1, then we get let's write it in red. So my is equal to substituting this and y equal to, so we know that the maximum bending moment will be having at the endpoints y equal to a by 2 and y equal to minus a by 2. So we take one of the case and we get y equal to minus 2, so minus 3.927 into 10 power minus 5 by 1.6 whole square 1 minus 0.3 cos a by y by a. Y by 2 plus 7.586 minus 5 pi by 2 plus 2 pi by a is 0.6 into cos h pi by 2 minus 0.3 into q, that is 500, 4 into 500 into 0.6 to the power 4 pi d to the power 5. d pi to the power 5 times sin by x by a. So if we take x equal to some, okay, so let me write this in. My max would be at x equal to 0 and y equal to b by 2, and that value in solving, sorry, at x equal to a by 2 and y equal to plus minus a by 2. So that would be my max is equal to, if you solve this thing, this value will give me that value, and it's around 7.27. Okay, so it's around 13.32 Newton meter per meter. Check it. Okay, let's move on to the last question of today's session. So we are given with a rectangular plate simply supported along all edges. Along all edges is subjected to uniformly distributed moment m along y edge over. The expression for the deflected line y equal to is given by this relation, where alpha is here. Given that a is very large compared to b, m equal to a, b, d, and deflection at the center of the plate. So what do we have? We have a rectangular plate x, y, and x equal to 0, x equal to a, y equal to b by minus b by 2, y equal to b by 2. It's simply supported along all edges. And along, so we have a distributed moment and along these edges we have the relation given a deflection relation as w equal to 2m a square alpha by k d tan h alpha upon cos h alpha sin pi x by a. Okay, where alpha is equal to pi b by 2a. It's given that a is very large compared to b. It implies uh, that b by a is much less than 1. Okay, so that means pi b by 2a is much less than 1. You can say it as 1 also, that's fine. So it says that alpha is much less than 1, so I can say alpha is almost tending to 0, and if it is the case, then I can write sin h alpha as tending to alpha cos h alpha is equal to 1, and tan h alpha as tending to alpha. Okay, as alpha tends to 0. Okay, so So the as alpha tends to 0, we have the W relation as 2ma square alpha pi cube d. Tan alpha will becomes alpha, this becomes 1, and sin pi x by a, correct? So we are given with the value of m as 100 meter per meter, a value as okay, b value and equal to 300 Newton meter. Deflection at the center of the plate. Deflection at the center of the plate. So first of all, deflection at the center of the plate. Center of the plate would be at x equal to a by 2 and y equal to 0. That would be equal to 2m a square alpha pi cube d alpha sin pi by a by 2. So this becomes pi by 2, this becomes 1. So finally it is equal to 2m a square alpha square pi cube d, right? So it is equal to 2 into 100 a square. What was alpha? Pi b by 2. Pi b by 2 a whole square pi cube d value is equal to 2300. So 200 pi cube into 2300 a square. We have pi square b square by 4a square. This cancels out. So we have finally 200 pi square will be cancelled out and we will be having as pi. So 200 b square is 0.5 whole square by 2300 pi into 4. So this gives me 200 into 0.5 into 0.5 divided by 2300 divided by pi and by 4. So this is equal to 0.2. I made a mistake anyway. 200 into 200 this. This is equal to 1.001729945 meter. So it's equal to, we say, 1.729945 millimeter. Up to second decimal place, W center is equal to 1.73 mm. So this is the final answer. So finally, W center is equal to 1.73 mm. Got it? Okay. So this solves the final question. If you have any doubt, please post it in the discussion group. Okay. Okay. Okay, so here let's end the session here. If you guys have any doubt, please post it in the group. Okay, guys, take care. Bye.